Hello guys, welcome back to another video. So in this video we are going to be exploring what is Docker and how we can use it in our day-to-day life, and what is the difference between a virtual machine and Docker. So in this video we will be learning what is Docker and what is the difference between a virtual machine and Docker, and what are the Docker components like images, containers, volume, and different types of Docker network that Docker provides. And then we will be exploring what is Docker Compose. So what is Docker? So Docker is an open source platform that enables you to build, package and run application in a lightweight and portable containers. It is widely used in software development and also scaling your application. It packages everything the app needs, including source code, runtime, system tool and libraries into a single lightweight unit. Docker uses host Linux kernel to run its container, so it will only work on operating system that has Linux kernel. So in Linux, Docker works natively. In Windows, you need to install WSL2, or you can install any hypervisor like VMware or VirtualBox. Then you can spin up a Debian or Ubuntu operating system. In Mac, you need to use a virtual machine. So the difference between a virtual machine and a Docker container is both are virtualized, but there is a difference. So in a virtual machine, architecture, we have our infrastructure on the bottom level, that is our hardware. Then on top of it, we use a hypervisor, let's say a VMware or VirtualBox or a KVM. And on top of it, we are creating a virtual instance, and in there we can install any operating system in there. So in each virtual instance have their own separate kernel. So in this way, we can install any operating system like Windows, Ubuntu and even Mac. And because it does not dependent on your host or parent kernel. But in Docker, it uses a different approach. So in Docker, we have our infrastructure. Then on top of it, we have our Linux operating system and kernel. And then on top, we are using Docker to create virtual containers. So these virtual containers does not have any kernel. So these containers are totally dependent on their parent kernel. So what Docker does is it create a link between containers and your parent kernel. Due to this, the performance is much more higher in Docker rather than your virtual machine, and the resource is less consumed, and the image size or container size is very much less compared to a virtual machine, because it does not have this extra kernel or operating system. So for this tutorial, I am using a Windows operating system. So I have already installed a VMware workstation player, which is freely available now. And I have created a virtual instance and installed Debian operating system in it. And next we will be installing Docker on there and continue with our tutorial. So this is our virtual operating system. I am using Debian 12. Okay. And what we will be doing is we will be installing Docker inside here. So to install Docker, we need to go to Docker official website and go to download Docker. And do not install Docker desktop because it has some limitation. So we'll be continuing with Docker engine, which is a open source. So go to install, and I will be installing for Debian. For Docker internal network, it is using IP tables. Scroll down. So it has supported Debian bookcom 12. Okay. First, what we need to do is we need to run this command. Okay. So let's go to our VMware, paste it, add this repository and run sudo apt-get update. Okay. So next we need to install all of these Docker packages. So let's copy this, paste it and install. Why? So after Docker is installed, we can run this command. So what it does is it just pull a hello world image from the Docker repository and run in your terminal. Okay. So to download any Docker images, you can go to Docker Hub. So go to products and click on Docker Hub, and you need to create a account in here and sign in with your account, and then you will be redirected to this Docker Hub. So we can go to Docker Hub and find any repositories. So you can search anything. So let's say Nginx. So let's search Nginx and click on it. To download this image and use it, you can just run this command, docker pull Nginx. You can search anything in here. Let's say hello world, search it, and you will see this is the command. So what it does is it's just download this sample image. Okay. So let's copy it. Okay. You need to run this command as a sudo user. Okay, so let's go to your terminal and paste it. Okay, so it does not find that image locally, so it is downloading it. So our Docker is installed correctly. Okay, we can also see this Docker images by running this. So to run Docker you need a sudo access, otherwise you cannot use it. So if we use sudo docker images, you can find these images. Okay, so if you do not want to use sudo with Docker, okay, we can do one thing. So go to post installation step and you need to add a group name Docker. Okay, so let's paste it in here. Okay, already exist, that's good. Then we need to add our user to that group. Okay, so let's add it. Okay, and then we can then we need to sign out. Okay, power of logout and login. Okay, let's log in here and let's see if we can run these commands. Okay, sudo docker images. Okay, let's remove sudo. Okay, docker images. Okay, now we can access it. So we need to run this command. Okay, so we can also remove these images. So after that we need to also enable docker service and docker container service so that it start on boot. Paste. Okay, so we have successfully installed Docker. So let's explore what are the Docker components. So first we have Docker images. So Docker image is a read-only template that is used to create containers. You can run multiple containers with a single image, and it is like a Windows or Linux ISO image, but it does not have its own kernel code. It does not have its own operating system. It is rely on your parent host kernel. So it contains app source code, dependencies, and some utilities. So to download images, we have already seen. So we use docker pull command to download images from Docker Hub. So let's see how we can download images from Docker Hub with Docker commands. So to list all the images, we can run docker images. So we have previously downloaded one image, hello world. Next we can, to download images from Docker Hub, we can just run docker run, then name of the image. So I will be naming nginx because we have that package in here. So let's say nginx. So we have a nginx image in here. Okay, so let's download it. So let's download it. So we have downloaded it and it is running inside here. So now it is running inside here. We need to close it. So we have closed it. So let's run docker images. We can see here we have this nginx. We can also remove that images by running docker rmi nginx. Because docker automatically run a container with this image, we need to first stop that container. Okay, so to do this we need to type docker container stop, then id. So id will be 6064. So I will be 6064. So after we stop that, we need to delete that container. So container remove. Okay, then we can remove that nginx image. Let's check it, docker images. Okay, as you can see our images has been removed. Okay, so a docker container is a running instance of that image. We can spin up as many as container with the same image. It is isolated and it runs the app. So in our case it is nginx. So let's see. So to run a docker container, we can use docker run. Then we need to define it. What is the way? So we will be running this container in a detached mode. That means it will run in background, and in interactive mode we will be redirect to this container terminal, and when we exit from the terminal the container will stop. So we will be running this in detached mode. Then we need to define a name of the container, which is totally optional. You can do it. So I will be naming this my nginx, and then name of the image. So nginx. So because we have removed nginx previously, so that's why it will download again and then run the container. So it is running the container, and this is the container ID. We just need to use this unique first 4 character to work with a container. Okay. So to list out all the running containers, you can run docker ps to list out all running containers. And if you want to list all of the running and stopped containers, you can write -a. Okay. So previously we have used hello world, which is stop currently now, you can see. And now we have running a nginx container, which is up for 49 seconds, and this is the container ID, and this is the container ID. We can directly access that terminal using this. We can also go inside that container. So we can run docker execute, then we need to tell it we need a interactive terminal, container name, then container name. In case it will be v0a9, we need to type bash, so it will open up. So now we can now we are inside that container, we can type ifconfig. So because it's a blank container, we need to first update it, and then we can install nettools. Okay, so it is installed. Now we can use ifconfig command. So as you can see, this is our loopback interface, and this is our ethernet. So this is the docker network. By default, docker create a bridge network. Okay, let's type this IP 1.727.0.0.0.2, and if we go to that IP, you can see this is our nginx. Okay, why we can access this IP is, if we go to a terminal and type, if we go to our host machine and check network interfaces, so in here we have a docker interface, which IP is from 172.17.0.1. So you can see here we have a docker network inside here, and our machine has a IP. Because we have accessed this IP and this subnet, we can access any containers that is running under this subnet. Okay, so that's why we can use it. Now if we want to expose this application to our host local network, like this localhost, we can do it by port forwarding. Okay, so let's go to our instance and exit it. Okay, docker ps. Now we need to stop it. Now we need to stop this. Let's remove this and spin up a fresh container. Okay, so we will run docker. So we will run the same same command, but now we will be having a port forwarding. So we will be forwarding our container 80 port to our localhost 80 port. Okay, so let's run the container, and this is the container ID. Okay, now we can also access this in our container ID, and also access this in our parent localhost. So now we can access this application inside our localhost port 80. Okay, because we have done the port forwarding. Okay, so if we stop that container, the application will also stop. So let's say docker, so docker container stop 3638. Okay, if we try now to access this, so this is our container port which is stop, and we cannot reach that site. Okay, so next we will be talking about docker volume. So docker provide 2 volumes, which is virtual drive and bind directory. So virtual drive is maintained by Docker internally, and it is present in Docker internal storage, which is preferred way to hosting any application in the production. But in local development environment, you need to modify your code frequently, and also run that application and test that application inside Docker. So for local development environment, we use bind directory, and for production we use virtual drive. So how we can do that? Let's see. So to check all the volumes, we can type docker volume ls. Okay, so there is no docker volume. We can create a volume by running docker volume create my volume. Okay, let's run docker volume ls. So you can see it is using local driver, and this is my volume. Okay, and we can attach this volume to any docker container. So if we stop the docker container or restart the docker container, the state will be persistent because we have created this virtual volume. So let's try this. We will be running same command. Now we need to attach a volume, so we can do this by, so now we will be attaching our volume to this path where we have this demo index.html file. So let's run it. So we have the docker id, so let's go inside that. So let's go inside it, c55b. So let's go inside this container. Okay, we need to add bash. So let's go inside this container, apt update. Okay, apt, we need to install nano. Okay, let's go inside usr share nginx. Okay, if we go there is html, so html ls, and we have this index.html file. So let's say nano it, nano index.html, and inside here if we change anything, let's say let's add a new line h1. Let's say this is persistence data. Okay, persistent data. Okay, let's save it, control o, save, exit. Okay, now if we go to this IP, you can see here this is persistent data, and because we have did port mapping, we can also see in here. So let's do, now let's exit from it and let's stop this container. So docker stop c55b. Okay, docker ps. Okay, so this is so these are all our containers. So let's start, so let's start again, and let's see if the data is persistent or not. So we have started it, docker start c55b, and let's check it. As you can see, our data is persistent. Let's stop it, docker stop, and if we refresh it, our application is gone. So that's how you can persist data with docker virtual volume. So next we will be exploring bind volumes. Okay, so let's create a folder nginx bind, and inside here we will create the same folder. Okay, so let's say data. So this is our local data directory. Okay, so let's run. So now let's run it. Okay, my nginx is already there. Okay, so let's run it. Okay, there are some error. Okay, docker ps -a. Okay, so because we have already a docker container named my nginx, so we need to name it to my nginx 2. Okay, so let's run it. So this is the docker container id. So let's go to that container. Okay, cd usr share nginx. Okay, let's see, we do not have anything. Okay, so we do not have anything. So let's create a folder html, and inside here we will be creating index.html. Okay, previously like that. Okay, let's do one thing, hello from docker. Okay, so let's see if it is working or not. So let's see if it is working or not. Okay, ls. Okay, so you can see here we have created one folder in here, and it is reflected to your container. So if we go to html, and say ls, we can found that. Okay, so index.html. So now we can go to that folder, refresh it, and you can see here hello from Docker, and inside here also. So that's how you will bind a local directory to your Docker container, and this is very useful for local development. So if we type anything in here, obviously it will be reflected to your container directly, so we do not need to restart or anything. So that is the benefit of local directory binding. In virtual binding, you do not have any access to that virtual container. You can access it, but it is much more difficult. But in local binding, you can directly bind your local directory to your container, and you can do any modification on the fly. So let's exit it from here. Okay, docker ps. Okay, let's stop this container. Okay, c5 stop. We can stop also by name. Okay, so next we will explore what is Docker Compose. So Docker Compose is a tool that lets you define and run multiple Docker applications. So you can configure all of your app services like database, API, frontend in a single YAML file and spin them up with just one command, that is Docker Compose up and Docker Compose down. And so let's see it. So I have created a directory named Nginx, and inside here I have created one folder for local directory mapping. So inside here there is docker compose.yml file. So here is our Docker configuration. So like we are doing in the terminal, we can do the same thing in here. So our first container is Nginx, and this is the image, this is the container name, the ports we are exposing, and this is the volume. Okay, so we are mapping this www volume to this user share Nginx volume. Okay, Nginx volume. So now ls, so we have this docker compose.yml file, so we can run docker compose of -d. So -d means detach mode, so the container will run in the background. So let's click it. If we click it, you can see here one network has been created because we do not define any network. So if you do not define any network, it will create a default bridge network for each container. And this is my container. So let's check it. Docker. So let's check it. Docker ps. So as you can see, our container is running. So it is running, and the port forward is also working. So let's check it. So let's check it. So localhost, you can see here hello from Docker. So this content is coming from this thing. Okay, this content is coming from this thing. And if we go to, and if we check our network interface in our host machine, you can see here. So previously we have our Docker default bridge network, which is 172.17, and there is also another network that is 172.18. So this is the Nginx default network. We can verify it. So Docker network. So you can see here name is Nginx default, and this is the subnet, and this is the gateway. So this is the first usable IP address, which is our host IP. So if we go to this IP, so we can also go to this IP directly to check this. So 172. So 172.18.0.1 is our host. Then container will be 02. Okay, so hello from Docker. So that's how you will run a container using Compose. The beauty of this, you can stop all the containers by running only one command, that is docker compose down. So if we down it, so if we run docker compose down, what it will do is it will stop the container. So it will stop the container. Okay, and also remove the Nginx default network that is created previously. Okay, so if we check, docker network ls, you can see here our custom virtual network is removed. So if we do not want to create any extra networks with our container, we can also do that. Network custom network, and by default driver will be bridge, so we do not need to define that. And next we can define this in here. So this is custom network, so custom network, and this external true, so it does not create its own network. So let's run docker compose up -d. So you can see here my nginx has started, but there is no new network is created. We can also check that network ls. Okay, so only custom network previously we have created is existed, and we can there is no extra network. Okay, in this way you can create multiple instances, let's say add a database and add a Redis server, and connect all these containers to a custom networks. So let's check the information. Docker network inspect custom network. So this is the gateway, and inside here you can see containers that are using this network is my nginx, which has a 172.18.0.2 IP address. So if we go to this IP address, you can see here it is working. Okay, so that's how Docker Compose work. So it is the preferred way to run any containers, because you can rather than writing command inside the terminal, you can write here the configuration and start all the containers at once, and also stop all the containers with one command. So let's run docker compose. Okay, so that's how Docker Compose work. With one command you can run all the containers, also stop and remove all the containers. Next we will be learning different types of Docker network and how we can use them. And that's all for this session. Thank you for watching. If you like this video, hit that like button and subscribe to this channel for more videos like this. So I will be sharing this entire project with a GitHub URL in the video description. If this video got 500 likes and 500 subscribe, so like and subscribe, and let's catch up in next video. Thank you for watching.